Why is this planet, though not perfect, making scientists increasingly uneasy? It's not too close to its sun, its temperature isn't too high, and it might even have liquid water, meeting almost our entire picture of a second Earth. But the more one gazes upon it, the more something feels wrong. Its size exceeds the upper limit for a rocky planet, yet it isn't bloated like a gas giant. Its position is perfectly situated in the habitable zone, yet it has no known moons or any companions. Every detail about it seems like some form of artificial design, not a coincidence, not an exception, but like the final version after the universe's repeated debugging, as if it wasn't formed naturally, but was manufactured. It is Kepler-22b, a planet that arguably shouldn't exist, but has become the most watched target in the astronomical community. Today, we won't just introduce its parameters, but dissect its anomalies to see what hidden information lies behind it. The discovery of Kepler-22b originated from an astronomical experiment focused on anomalies. In 2009, NASA launched the Kepler Space Telescope. It didn't take pictures. Its sole mission was to monitor 150,000 stars in the Milky Way, waiting for subtle changes in their brightness. Why do this? Because when a planet passes in front of a star, it slightly blocks some of its light. This method is called the transit method. It sounds simple, but its execution is incredibly challenging. Like lighting a candle 100 kilometers away, then sitting at the foot of a mountain, staring at that tiny light, waiting for a mosquito to fly past. Kepler had to capture this 0.1% change in brightness, and it had to see the exact same rhythm 3 consecutive times to confirm it was truly a planet. What's even harder is that the orbital angles of most exoplanets don't align with our line of sight, so they never appear in front of their star for us to see. Therefore, what Kepler could see was just a small handful of planets that happened to pass by. And Kepler-22b is the miracle that was precisely captured under such low probability conditions. It orbits a sun-like star named Kepler-22. The telescope detected that the star's brightness dipped slightly every 290 days, each time by 0.01%, as if a regularly moving object was grazing its edge. After 3 instances, scientists realized this could be a planet. Relying on transit data alone wasn't enough. They spent 2.5 years using multiple ground-based and space telescopes to cross-check repeatedly, eliminating all possible errors, ruling out interference from binary star systems and false positive mechanisms. In 2011, the existence of Kepler-22b was confirmed. It was the first time humans had confirmed an exoplanet within the habitable zone of a sun-like star. This wasn't just the discovery of a planet, but the confirmation of another world where life could possibly exist. From that moment, space exploration entered a new era. Kepler-22b is 600 light-years from Earth, orbiting a G-type star very similar to our Sun. It completes one orbit in just 290 days, at an orbital distance of 0.85 astronomical units, placing it perfectly in the golden zone of the habitable region. If it possessed an atmosphere similar to Earth's, its surface temperature could be maintained at around 22 degrees Celsius, precisely the most comfortable spring-like climate for humans. This sounds almost too good to be true, but the more perfect it seems, the more anomalous it becomes. The planet's size is 2.4 times that of Earth, and its density remains a mystery. It's too large to be a rocky planet, yet it's too small to be a gas planet. It falls right into a fuzzy area known as the Fulton Gap, a place where theoretical models suggest planets should hardly exist. The solar system has no planets of this size. If you had to make a comparison, it would be like seeing a gorilla standing 2.4 meters tall with a muscular structure that doesn't conform to a human's. You would have no idea what category of creature to place it in.
Even more absurd is that its orbit is nearly a perfect circle, with no eccentricity and no visible perturbations, as if it were precisely calculated and placed in the star's golden orbit. It has no moon, no companions, and no other planets orbiting the same star. The entire system is abnormally clean. Scientists examining its light curve felt it didn't seem like a real planet, but more like a standard model running in a cosmic simulator. Sometimes, being too ideal doesn't seem like a product of nature. And precisely because we have no clue about its structure, it has become the most difficult type of planet to define. It could be a rocky planet, a gas planet, a water world, or perhaps a completely new type we have never encountered. So what is it really? Scientists have proposed 4 hypotheses, each like an attempt to solve a riddle, but none can fully explain it. The first hypothesis, it's a rocky super-Earth, enveloped in a thick atmosphere. This is theoretically plausible, but the greater the atmospheric pressure, the higher the temperature. If it's like Venus, its surface could be a perpetually boiling high-pressure cooker. But if the atmosphere isn't thick enough, its size cannot be explained. Simulated countless times, it always gets stuck at a critical point of being neither hot enough nor cold enough, as if adjusted by an unseen hand to 99% but never reaching 100%. The second possibility? It's an ocean planet, completely covered by a global ocean hundreds of kilometers deep. Sounds dreamy, doesn't it? But with no continents and no geological activity, there would be no nutrient cycle. Even if microbes existed, they might remain forever in their most primitive state, unable to develop into a biosphere. This is a planet that seems difficult, but might just be a dead water world. The third possibility? A mini Neptune. It might not be composed of rock, but be a small-sized gas planet. But here's the problem. Its orbit is too close to its star, completely unlike the position this type of planet should occupy, unless it initially formed further out and was later dragged in by something. What dragged it in? And what force keeps it perfectly stable in its new orbit? The fourth hypothesis, it's a hybrid planet with a composite structure, possessing a rocky core, a water layer, and an atmosphere, forming a multi-layered body. Simulations show that such a structure is theoretically possible, but its evolutionary path is extremely complex, requiring incredibly precise initial conditions. In known evolutionary models, this scenario is virtually impossible to produce. Every guess leads back to the starting point. Every model feels like reality being forcibly crammed into the cracks of an assumption. So the question becomes, could our models be wrong? Scientists, of course, are reluctant to accept the notion that we've misunderstood the universe. Their initial reaction was to doubt the data. So they checked their instruments again and again, compared spectra, analyzed orbits, eliminated noise, false positives, and every possible illusion. But the result of the checks led to only one conclusion. It truly exists. Some have also suggested that it might have originally had companion planets that were lost due to some past event, but the Kepler-22 system looks too clean. No debris, no orbital disturbances, no traces of historical catastrophes, like a newly renovated and spotlessly clean laboratory.
So the questions are, why does it exist? Why does it fit so perfectly at the optimal point of a series of parameters? This planet shatters the classification system we built based on our solar system. It doesn't resemble any planet we are familiar with, yet it happens to possess all the prerequisites for habitability. Its existence forces us to admit a truth. Perhaps our understanding of planetary logic is merely a special case, not the general rule. And what is most spine-chilling is that not only is its structure anomalous, but its parameters are too perfectly aligned. Its size is exactly 2.4 times Earth's, right on the edge of the Fulton Gap. Its orbit is perfectly within the habitable zone. Its orbital period is close to an Earth year. Its theoretical temperature, assuming an atmosphere, is precisely the 22 degrees Celsius most comfortable for humans. A series of just rights. If it happens once, it's a coincidence. Twice is luck. 3, 4, 5 times? Then it becomes suspicious. We certainly can't speculate that it was created, but if a planet looks like a sample planet that has been manually adjusted, then we have reason to ask, was it never meant for us to see in the first place? Is it an invitation, a reminder, or a specimen in some cosmic experiment? It may not provide us with answers, but it forces us to ask new questions. If the universe truly left behind such a sample planet, is it trying to tell us something? Or, to be bolder, if a planet looks as if it were created, then are we